Hi all, this is Eric. So now we're gonna continue with part 2 of the second episode, which is understand the code of the midnight examples. Let's just do a recap of what we did on part 1. We learned how to write a smart contract using compact, and we learned as well how to write and how to define our oracle. Then using these two components, we ran some tests and then we built our smart contracts, and then we had an output. So now we're gonna learn how to create a class for our contract using the APIs, and then establish a workflow where we can see and execute our contract and see how all these components fit together to actually execute a smart contract. So let's start doing that. So before going deep into the code, let's understand what we want to accomplish. So at the end, we want to actually do these three things with our contract. We want to deploy a contract. We want to join a contract created by us or created by somebody else, and run the circuits. In the case of our counter contract, we only have one circuit, which is increment. So to better understand, we're gonna use this design that we saw in the first part, but now we're gonna see it with more details. So down here on the bottom left, we can see that we have the compiler, right? And at the output, and that's something that we learned during part 1, we have this as an output. We have the definition of the oracle, we have the definition of our contract, and we have some cryptographic outputs as the keys for the prover and the verifier, and we also have a CKIRs, which is the zero knowledge intermediate representation. Then, using this output plus the providers plus the midnight APIs, using all these, we're gonna be able to write code that is gonna let us deploy a contract, join a contract, or run some circuits. Okay, so now you might be asking, what are the providers? What is a provider? For that, I have represented providers as a check here in the design, so you can identify what are the providers in this graph, and we can identify some of them. Just a remark, the providers, they are really modular, and we can grab some providers that are already defined by the Midnight team, but we can actually change them or define some others depending our needs. So let's see here in this design, what are the providers? We have one here of an indexer. We have another provider related to the node. We have another provider for the proof server. And then we have another provider for the wallet, in this case, Lace. This provider, the wallet, we can actually define it for browser, and we can create it as well for node runtimes. Then another provider, it's the oracle. So what's the difference between the provider oracle and the definition of oracle? In the first part, we defined the definition of oracle that integrates with the contract. But in this case, the provider, it's the one that actually established the rules where to store that information, that private information. And then we have another provider for the cryptographic information. So at the end, what happens here? In our DApp, using the APIs, we're gonna have access to these different providers to have some features to perform these actions. Okay, so now we are ready to go deep into the code of the counter CLI. So if we go into the repo and open the folder examples and go to counter, which is the example that we are taking a look at right now, then we have these two folders, contract and contract CLI. The contract is that first part that we have already studied. If we go to this diagram, that part corresponds to this part, right? That after compilation, we got this output. Now we want to talk about the CLI part, which consists on using the Midnight APIs, using the providers, and creating a class for our contract. And that class is going to give us the functionalities necessary to be able to deploy our contract, join a contract, or run some circuits. Perfect. So let's go to the Contra CLI folder. Let's open it. And we can see all these files within. When I enter into a new project, what I do first is go to the package.json so I can take a look at what are the scripts available so I can have a macro idea of what is possible within that package. So let's open the package.json and we can see some scripts. Let's focus on these four first scripts. We can see a testnet remote command, a testnet remote ps command, a testnet local command, and a standalone command. Let's see the code to execute these commands. In the standalone, we can see that we are using the command docker compose, and we are referencing a YAML file, standalone. For the others, we are just running the node command, right? Okay, then we can see that what are the files pointing to each of these commands. For testnet remote, we are running the testnet remote file. For the testnet remote ps command, we are executing this file over here, testnet remote start proof server. For the testnet local, we are executing the testnet local. And for standalone, we are executing the standalone file. What are those files? If we take a look at our source, we can see that we have four files over here: standalone, testnet local, testnet remote start proof, and testnet remote. Those files are these files that are being executed by running these commands. So let's open one by one to see if there's any common pattern that we can take a look. Let's start with testnet remote. So here we can see a command run that it's being imported by from the file CLI. And run, we pass two props. One is a config, another one is a logger. The config, it's an instance of this class, testnet remote config, which is being imported from the file config. The logger, it's just a instance from our logger library. In this case, we're using the function create logger that is being imported from logger utils. This is just boilerplate, but we are gonna open it just for you guys to take a look. Logger utils. We can see here that we're using the library Pino to implement our logging system. Okay, so well, let's see now the other three configurations, and we're gonna be able to see that we use again this run command and this config command. So let's go one by one. Standalone. Standalone, we can see that we have that run command that we saw in testnet remote, and we are passing a config configuration that it's an instance of this class, standalone config, that it's being imported from the folder config, which is the same from the testnet remote. And we are passing a logger. In this case, we have a new prop, which is a Docker environment. This Docker environment, it's being initialized by this command, docker compose environment, that it's being imported from the library test containers. So we're going to take a look at this later, but we can see here that we have a Docker environment in this run. Let's see the other one, testnet local. Testnet local, we have a run command, a config that it's an instance of this class, the same one as we saw before, and a logger. And for the testnet remote, again, we have a run command, we have a config that is an instance of that class, we have a logger, and we have a Docker that is being initialized by that command from testnet containers. Perfect. So now let's go deep into one of those configurations and understand better what are each of these files being imported. Excellent. So now let's go deep into one of those configurations, which is testnet remote config. So where we can find that class, it's inside this folder, config.js. So if we find that folder, in this case file, config, we can see that we have different classes. Testnet local config, standalone config, testnet remote config. So these classes are being used by these different configurations depending what the way we want to work our code. So let's take a look at standalone, for example. In standalone, we are importing the standalone config class. And testnet remote, it's importing the testnet remote config class. So these are the classes, different classes, being imported by the different configurations. Okay, so now all of them are being implemented by this config, which has these different outputs. A directory for our log, our indexer, the WebSocket of the indexer, a node, and a proof server. Okay, so when we initialize one of these classes, we first run this command, the constructor, which then runs the set network ID. What is the set network ID? If we go up here, we can see that this function is being imported from the Midnight package. And what it actually does, it says to the other libraries from the Midnight package, what is the network that we want to run on. So in this case, we're saying, okay, we want to use the testnet network for this class, testnet local config. For this other class, standalone config, we are saying, okay, we want to implement this on the undeploy network. And for the testnet remote config class, we are saying that we want to run on the testnet remote config, on the testnet remote network, sorry. So then we define other variables. In this case, logdir is the directory of our log. So we initialized, right, our logger. So this is the file that where all the logs are going to be stored. So in this case, we're defining a path that is going to be under this address. For all these classes, we're using the same path. You can see here that we are defining this log under this path, and it's the same for both the standalone config and the testnet remote config. Okay, let's take a look at the other variable, the indexer. So just to make sure that you are correlating these names with our diagram, we can take a look here that the indexer is this instance over here, right? So For the testnet local config, the indexer is gonna be found on this local address at port 8088, and the indexer WebSocket is going to be under the same address and port, but indicating that it's a WebSocket. For the other class, standalone config, the indexer and the indexer WebSocket are going to be linked to the same address and the same port. And for the testnet remote config, we can see that there is a difference. The indexer, it's being hosted on a external address. In this case, indexer.testnet02.midnight.network. And the indexer WebSocket, the same address and port, but indicating that it's a WebSocket. So we can see here a difference between the testnet remote and these other two classes, standalone and testnet local config. Now let's take a look at the node variable. Just to correlate with the diagram, this node is this instance over here. Okay, so for the testnet local config, the node is going to be linked to a local address and port 9944. For the standalone config, it's going to have the same address as this first class, a local address and port 9944. For the testnet remote config, there's a difference. The node is going to be linked or hosted by at an external address that is being hosted by the Midnight team. So it's going to be under rpc.testnet02.midnight.network. So again, there is a difference of this class and these other two. And lastly, we have the proof server. In the diagram, we can find this instance over here. This is the proof server. So for the testnet local config class, we are pointing to a local address and port 6300. For the standalone config, we are pointing to the same local address and the same port. So you might be asking, what is the difference between the testnet local config and the standalone config, since we're using the same addresses for all the indexers, node, and proof server? Well, in the constructor and the set network ID, we are pointing to two different networks. In the testnet local config, we can see that we are using the testnet network. And for the standalone config, we are using the undeployed network. So that's the difference between these two classes. And lastly, for the testnet remote config, the proof server, we are using a local instance as well. So we're going to be using a lot this class because we are using instances being hosted by somebody else, in this case Midnight team, for the indexer and node. By the proof server, we're going to run it ourselves using Docker, since the proof server receives our private information. So we want the proof server to be run by us locally, right? So now we're going to understand this other environment, which is the Docker environment. We already studied what is logger, what is the config, and we mentioned about the Docker env. This instance, it's initialized using this Docker Compose environment that it's coming from the test containers library. And to initialize this, we have to pass a YAML configuration. In this case, for the standalone config, we are using the standalone YAML configuration. We can find this following this path. So if we go here on the left, we can see here that the standalone YAML, it's here. So let's open it. And we can see that we are defining in this YAML three services. One is the proof server, the other one is the indexer, and the third one is the node. Each one has a image. Perfect. Then we follow some strategy for initialization. For the proof server, we're gonna wait for this message. And for the indexer, we're gonna wait for this message. Excellent. Another configuration that uses this Docker environment, it's testnet remote start proof. So we can see that we are using this Docker environment, using the same command from the testnet containers library. And in this case, we're using this other YAML configuration, proof server testnet. So if we go to that path, we can find this configuration here, proof server testnet YAML. So if we open that file, we can see that in this case, we are only using one service, which is a proof server. And we have the image over here. And we are using a strategy for the proof server to wait for this message. So excellent. We have understood now what is this Docker environment that we are passing along these other two configurations, logger and config, to the function run that it's coming from the CLI. So now we are going to understand this function over here. Excellent. So now we are ready to take a look at the run function that we saw that it's inside this file, CLI. So let's open it. And in here we can see many other functions, right? But let's start with the run, that it's the input, the first input to our TUI. So here we are declaring a function that we are passing config, logger, and Docker environment that we saw previously. So the first thing we do in the run function, it's we initialize a logger with the logger that we just passed. Then we call an API. So where is that API coming from? Let's take a look. So if we go up on this file to see the imports, we can see that the API, it's representing all the functions coming from the API.js file, which is this one here. So down here, we can see that we are calling API and the function setLogger, and we are passing the logger that we initialized before. So let's take a look at this setLogger function. If we go to API, here we're gonna find that function. We can look through all the functions, but it's easier just to click on the function. That's a feature provided by VS Code. So if you just control click setLogger, it's gonna send you directly to that function. So we see that we have here the function setLogger, and what it's actually doing is just initializing a new variable called logger with the logger that we just passed. So what is this logger? If we take a look at the top of this file, we can see that we are declaring a variable logger, and this variable is going to be used by other functions. So we are just initializing a global variable being used by other functions. Perfect. Then we are initializing the interface of our TUI that we call RLI. And we are using the function create interface, input and output. So this is boilerplate, and we are using embedded functions from Node. If we take a look where these functions are coming from, we can see at the top that we are importing create interface, standard in as input, standard out as output from Node process and Node readlines. So the way to configure the interface is by calling the function create interface and passing inputs and outputs as an object. Perfect. Now we declare a new variable that we're gonna call env, and we're gonna follow this procedure. So let's take a look what these lines of codes are doing. First, we take a look if we have any Docker environment that we are passing to the function run. we have seen that we have these different configurations: standalone, testnet local, testnet remote, and some of them actually passes a Docker environment and others they don't. So here we are taking a look if we are passing that environment. If we actually passing an environment, what we do next is we run the command app, and the output we're gonna define it on env. So what is this app doing? It's this what it's this doing. It's initializing the instances using Docker. So now that the instances are up and we have this env variable, what we do next is, if we are in the standalone config, we are gonna update the addresses of the indexers node proof server that were under the config. If you remember, the config had addresses of those instances. But now that we initialize those instances running Docker app, what we actually need is to update the port of those instances with the addresses that we previously configured. How we do that is by using this function, map container port. So if we take a look at the map container port function, it's up here. We are passing the env, that is a started Docker Compose environment that we just got it from running docker env app. Then we pass a URL. What is that URL? That is a string. It's config indexer. And then we pass the container name, that it's container indexer, container node. Where these names are coming from, we saw the YAML's configurations, right? So if we go into a YAML, we can see here that each of these images, they have a name. Perfect. So let's take a look at this function. What we are doing, it's this is string, so we are making it a URL to have a URL structure. And once we have that structure, we are running this command get container from the env to actually know what is the container that we want to take a look at. And with that container, we run the command get first map port. So that's actually getting the port that it's running in the Docker instance. And now that we have a URL, we are taking a look at the port part of the string and updating that value with the actual port of the container. And we are passing that as an output. So we see here that we are running that function for the indexer, for the WebSocket of the indexer, for the node, and for the proof server. So at the end, we are just updating the ports of the different instances with the correct ports of those running in Docker instances. Excellent. So now that we have that configuration done, we can summarize the rest of the TUI by these lines of code. So we can see here that first we are declaring and running a wallet by running this function. Then we are configuring our providers. And lastly, we are gonna run the main loop. Okay, so now we're gonna start taking a look at this function here, build wallet, that we're gonna use to build our wallet. So if we go to that function, we can see that we have declared that function up here. We are passing the config and we are passing the interface. And we're gonna run different commands depending of this if. If the config it's an instance of an standalone config, we're gonna run this. And if it's not, we're gonna go through this loop here. So what is this standalone config, right? So if we go back to the to our graph, what we are looking right now is to configure our wallet. And if we remember what we mentioned before, we can configure that wallet as a browser instance or as a node instance. In this case, we're going to configure it as a node since we're using node to run it. And also, depending on the network, that could be undeployed if we're going to host the instances ourselves, or if we're going to run in the network testnet, that is going to change the way we configure this wallet. So if we go back to the code, we can see here, if it's in standalone, meaning if we are in the undeployed network, we're gonna run this command, API point build wallet and wait for funds. We're gonna pass the config and we're gonna pass the Genesis min wallet seed. What is this Genesis min wallet seed? If we take a look up here, we're gonna see that it's an address that ends with 1. So what is that address? If we go back to the graph, what happened is when we are deploying our wallet on a undeployed network, when we create a wallet, we already have funds in our wallet. So to be able to have funds, we have to configure our wallet using an address that it's being configured for that purpose, which in this case, it's this address here. If we use another address, we are not going to have funds in our undeploy, and we are not going to be able to fund our wallet. So we have to use this wallet address when we're using the undeploy network. If we are using the testnet, what happens? We can use whatever wallet we want. We using whatever seed we configure, and then there's gonna be a faucet somewhere here, and we have to request funds from the faucet to send those tokens to that wallet that we just configured. So if we are not using the standalone config, then we're gonna run this loop here, right? So what happens? We're gonna store in a choice the answer from the user. So we are using the interface and passing the method question. So we're gonna ask our user this. So what is this wallet loop question? If we look at up here, we can see that we are sending this message to the user. You can do one of the following. Option number 1, it's build a fresh wallet. Option number 2, it's build a wallet from a seed. And option number 3, it's exit. So the client, the user, is gonna write 1, 2, or 3. And depending on the choice, we're gonna run these different commands if it's 1, 2, or 3. If it's 1, that it's build a fresh wallet, we're gonna run a function from the API that is called build fresh wallet, and we're gonna pass our config. If it's option number 2, we're gonna run the function build wallet from seed. Where is this function coming from? So let's take a look over here. So we're passing our config and we're passing the interface, and this time we're asking a new question to the user. Enter your wallet seed. And then we are running the function from the API build wallet and wait for funds, and we're passing config and we're passing the seed that the user just entered on the tool. And if it's option number 3, we're logging exiting and we just return null. So summarizing, at the end we are running 2 functions coming from the API. One, it's build wallet and wait for funds, and the other one it's build fresh wallet if we are creating a fresh wallet. One difference here is that this build wallet and wait for funds, we can pass a seed, and in one we are actually sending a seed that was provided by the user, and in this case here on the standalone configuration, the seed that we're using, it's from the Genesis Mint wallet seed. That it's that pre-configured wallet with funds that we can use when we're using the undeployed network. Okay, so now let's take a look at this function here, build fresh wallet. If we click that function, we open that function from the API file, and we can see that we are passing the config, and this function is gonna return a promise with our wallet that has this type, wallet and resource. So the function that we're running within this build fresh wallet is this build wallet and wait for funds function. One thing to take in consideration is that from the CLI, I mentioned that we are basically we're running these two functions from this build wallet function, the build fresh wallet and the build wallet and wait for funds. Both functions at the end, they end up running this one here, build wallet and wait for funds function. The difference is that the seed phrase, one it's being provided by the user, and the other one it's being created by us, the developers. Since the user said, I don't have a wallet, I don't have a seed, so I want to create one. So we're using this function to create a seed phrase. So let's see how we create that seed phrase using the random bytes function. We can see that the function is over here. So we are passing a length, which is 32. And what means that 32 is that our seed phrase is going to have 32 bytes. So we're using uint array, passing the 32. So we are creating a array of 32 bytes. And then using the method of the crypto library, get random values, we are filling that array with random values. So we get 32 bytes with random values. So that's going to be the new seed phrase that we just created for our user. And we are passing that to this function. So if we go now to this function here, we can see that we're passing the addresses of the indexer, the WebSocket, the node, the proof server, and we're passing the seed, one created by our user and the other one created by us, the developers, and a third one that it's a file name. So what is this file name? If we go back to the CLI to see the function calling this one here, we can see that both the one provided by the user and one created for us, the seed phrase, we are not passing any value. We're passing an empty string for the file name. So what is this file name? If we take a look at the implementation, we can see that we are running an if to make sure if we are using this file name. And if not, we execute something else. So since we're not using the file name, we are not going to go deep into the implementation, but I will mention what is this for. So in file name, what we are doing is we are using the serialize method of the wallets. So at the end, what is this serialization of the wallet? When we create a wallet from zero, we have to synchronize it, and it takes time. So we have an option to save a part of the wallet. So when we start the wallet again, we don't have to synchronize the wallet from scratch, from zero. So we just start from point X, for example. So at the end, this translates in faster synchronization for the wallet. But well, in this case, we're not using this file name. So this if method, we are just gonna pass it since we don't have that synchronization, this file name, and we are gonna execute just this part of the code. So what we are doing here is that we are using this function, wallet builder. So this is the function that we're going to use to create our wallet. Where is this function coming from? If we take a look up here, we are importing this wallet builder from the Midnight SDK package, from the wallet package specifically. So what we need to pass to that function, we're here. We are gonna run the method build from seed, and we are passing the addresses of the indexer, the proof server, the node, the seed, the network ID, and an info. So in this way, we get the wallet instance. So now we just have to start, and the wallet synchronization will commence. Perfect. Now that the synchronization started, we still need to run this following code to make sure that our wallet is synchronized and that we have funds in our wallet. So let's see how we can do that. So first, we want to know the state of our wallet. For that, we're gonna run the first value from the RxJS library, and we're gonna monitor the observable state. So with the instance wallet point state, we get an observable. This is something that the wallet implementation gives us. So anytime the state of the wallet emit a new value, this first value from will give that value to the state variable. So now we are logging the seed and the address of the state, and then we are declaring a new variable, balance. So this balance is going to be a value from the object from the state. So state balances, and we just want the native tokens, which in this case it's tdust. So now, if this is true, we will implement this code here. If not, we're gonna return the wallet as a response from the function that we saw at the beginning. If the balance is undefined or the balance is equal to 0, what is going to be the case when we initialize a wallet from scratch, we're going to log your wallet balance is 0, waiting to receive tokens, and then we're going to run this function here, wait for funds. So we're going to be waiting for funds. Let's see how we implement this function. If we click here, wait for funds, we can see here that we are using the first value from RxJS again, and we are monitoring the unobservable that we get from running wallet state. And then we run the pipe to execute the following code. So this is going to be a pipeline. Only if this pipeline returns a value, we're going to get a value from this first value from. So the throttle time, saying every 10 seconds, let's do something. Let's emit a value. And that value, which is going to be the state, we are just going to log some state, and then we're going to filter that state. So we are getting the sync and the total from the state object, and we're making sure that this is true. So making sure this is true, we are guaranteeing that our wallet has been synced. If that's true, then we're going to use the map method, and we're going to make sure that we have some native tokens. And in case we don't have any native tokens, we're going to return 0. And then if I have any balance, then I will return a new event. In case I don't have a balance greater than 0, this filter will not be true, so no events will be emitted. So perfect. So at the end, this first value from is just going to return values when our wallet it's sync and when we have funds in it. So if we go back to the CLI, we were executing these commands here, right? That we were explaining, and then we run this build wallet to get our wallet. So this one, it's all the code that just explained, that we're gonna initialize our wallet, we're gonna wait for it to be synced, and we're gonna wait for it to have funds. Only then we're gonna have a wallet, and then we can continue with this code. Excellent. So now that we have already configured the instance of our wallet, we're gonna define the providers. We're gonna use this function from the API that is called configure providers to define our providers. We are passing the wallet instance to this function. So let's see the implementation of that function. If we click here, we're gonna open the implementation. We can see here that the output of this function is gonna give us an object with 6 providers. 1, 2, 3, 4, 5, 6 providers. If we take a look at our diagram, we can see that I mentioned that we have some providers, right? And I marked as a check to those providers that we have here. So we see 1 provider, 2, 3, 4, 5, and 6. So we can see these providers being as an output from this function. So let's see how they are implemented one by one. We can see this first one here that is called the private state provider. The private state provider corresponds to this one here, private state provider. So how we implement that? We are using this function, level private state provider. This function is provided by the Midnight SDK, and to implement it, we have to pass this this type, that it's private states. Where is that type coming from? So we click this type here. We go to this file, common types. So this is a new file that we are taking a look at, where we're gonna implement all different types that we're gonna use through our implementation of the contour CLI. In this case, we're using the private states, and this one is an object of a counter private state of type counter private state, and this state we define it when we implemented our contract. So remember, in a file called witness, we define a oracle, which is a empty object, and a type of our private information that is going to be an empty object, defined like this. So this is the type that we're using here to define our private state. Perfect. And then we pass an object with a private state store name, and we're gonna give a name to our private state implementation. In this case, that name is coming from this contract config that is coming from this file config. So this is an object where we're defining the name of a private state store name. In this case, it's called counter private state, and we are also defining a ckconfig path. This path is where our output of the compilation of our contract is stored. In this case, we can find that under contract dist managed counter. So just to make sure that we have the output, we can go to the contract file under dist managed counter, and we can see the output of our compiler. Perfect. So that way we already configure this provider, the private state provider. Really easy. The implementation is already provided by the Midnight SDK. Now we're gonna define the public data provider. Again, this implementation, it's implemented by using a function provided by the Midnight SDK called indexer public data provider. And we just have to pass the addresses of our indexer and the indexer WebSocket. And that's it. Now let's configure the ckconfigure provider. Again, we initialize a class provided by the Midnight SDK called node ckconfig provider. We specify the name of our circuit that is called increment, and then we pass the path, right, from this contract config that we just saw. Then, well, just to connect, we were talking about these three providers: private, public, and ckconfig. The private is this one here. The public provider is this one here, our indexer. And the ckconfig provider is this one here. Okay, so now let's go to the fourth, the proof provider. This provider corresponds to this one here, our proof provider. So how do we implement that? Again, we're using a function provided by the Midnight SDK called HTTP client proof provider, and we are just passing the address of the proof server. And now we have two additional providers that we need to configure. That is the wallet provider and the Midnight provider. These providers corresponds to this one here and this one here. So the way we want to implement that, we can see that implementation is under wallet and Midnight provider, and this variable it's configured running this function, create wallet and Midnight provider, and passing as an argument the wallet instance. So let's take a look at this function. We click in that function, we can see that we have this implementation. Most of this code is boilerplate, so don't worry if you don't understand the details, but nevertheless, we're gonna take a look at the implementation so you can see how this function is implemented. So first, we want the state of our wallet. So we pass the wallet instance as an argument. So we're using this instance and obtaining the state. This is gonna be an observable. So if we run the first value from, we're gonna obtain a value from that observable. Then we wanna have as an output an object with three values. One is a coin public key, another is a balance transaction function, and the other one is a submit transaction function. The coin public key, we already obtain that value from the state variable, and we get the coin public key. If we take a look at the state variable, we can see that we have different options, but the one that we want is the coin public key. The balance transaction, we want to create a function that takes as parameters a transaction that its type, it's an unbalanced transaction, and it has another argument as a new coins of type coininf. And as output, is gonna have a promise of type balance transaction. If you take over here, this balance transaction processes this transaction so that the output of that function it has the same, it has a configuration and a structure that it's allowed to run under this other function, that it's submit transaction, that has this type, balance transaction. So let's take a look. This balance transaction, we first run a method of our instance called wallet that is called balance transaction, and we pass that transaction. This transaction, we have to serialize it, define the network ID, then deserialize it, and run it under this object, cswap transaction. Then we have to prove the transaction, and finally we again have to serialize and deserialize under these two objects, cswap transaction and transaction. And lastly, we just run the create balance transaction. All these functions and objects are provided by the Midnight SDK. And then the submit transaction, we accept this transaction of type balance transaction, and we submit it. We submit it by running the method of the wallet instance called submit transaction. So in this way, we have this implementation called create wallet and Midnight provider, and we assign it to the object of the output of the providers. So in this way, we already have the configuration of all 6 providers. So now we already have a wallet implementation that it's sync, and we have funds, and we have the configuration of the providers. So now we are ready to run the main loop, passing as an argument the providers. Okay, perfect. So now we are ready to see the implementation of the main loop function. Now that we have the wallet sync, and we have implemented the wallet, and we have configured the providers. So if we click to see the implementation of the main loop, we're gonna see this function. The exact details of each function, we're gonna go in detail in the next chapter. But let's take a look. Let's take a look here of what we're gonna see in the next chapter. So we are passing the providers, and in this first function, we are deploying, or we are joining a contract. And the output of this function, it's going to be if we click here, we're going to see that it's of type deploy contract. So it's actually a contract that has been deployed in the blockchain. And with that output, we can pass it as an argument of these other two functions. That one is going to be responsible to execute a circuit of the contract, which is increment, or to see a specific state of the contract, passing the providers and the contract. So with these functions, we're going to be able to perform these actions here. We're going to deploy, we're going to join, we're going to run a circuit, or we're going to see a state of the contract. So that's the main goal of the next chapter, after having learned how to define the providers, how to initialize our wallet, and to know some of the APIs provided by the Midnight SDK. So just to give a summary related to the documentation, we are putting everything together in this link, midnight.meshjs.dev. So in here, you're gonna find everything related to what we are doing with Midnight in Mesh, some documentation and the examples. In this case, we are taking a look at the Midnight examples. So if we click here, we can see here that we have so far 2 episodes, build and run. This is the first episode that we learn how to build and how to run the Midnight examples. And the episode 2 is where we are learning and understanding the code within the repository. So far, we've provided the part 1, where we learn how to compile the code, how to run the smart contract of the counter example. And now in part 2, we learn how to configure the wallet and how to initialize the providers corresponding to the counter CLI part, right? In next chapter, we're gonna learn how to execute these actions here, right? So all these videos are gonna be displayed in this documentation. You can see here the videos of part 1. Now we're gonna put next the links of the second part, and so on, right? When we have more examples, we're gonna put all the links in this one here. In the future, we're gonna have some other examples, as you can see here: auction and tokens, battle, voting, AMM. This is work in progress. Okay, another source of documentation, it's our GitHub, that it's a repository called Midnight under Mesh.js organization. Inside, you can find all the libraries and packages we're building. You can find the docs, and you can find the examples. So if you click in examples, you can find the example that we're working right now, that it's Midnight example 0.20. If we go inside, we can see here the structure of this example, right? We have the examples, and we are taking a look at the counter example. So that's it for this chapter. See you in the next one, and take care. Bye bye.